So guys, in this video I will try to cover the gamma function and also the beta function So basically first I want to tell you what is the integration form of gamma function and what is the use, right? Not what is, you can say what are the uses. So first of all, gamma n is equals to 0 to infinity e to the power minus x to the power 1 n minus 1 dx. Now basically this is the integration form of gamma n, and when it will converge when n is greater than 0. Now basically uh, definitely x will be also greater than 0 because we are taking 0 to infinity. Very nice. Now basically gamma function is nothing but the generalized form factorial function. This is the relation between gamma function and factorial function. Now basically uh, when we will deal with some kind of half factorial or 0.7 factorial, in that case we will deal with gamma function. It is nothing but the generalized form of factorial function, as I had told you. So first I want to show the proof of 0 factorial is equals to 1. As you know, using the basic rules, some like n factorial is equals to n minus 1 into n minus 1 factorial into n or something like that. Using that formula you can easily prove, but in that video I will talk about the using of gamma function. There are multiple uses, like if we have to find out this kind of factorials, then we can use gamma function. uh, if you have heard about the hyperellipse, then you also know if we want to find out the area, then we have to use the gamma function, or you can say beta function. Ultimately we have to use the gamma function because like we have to convert the beta into gamma. We have to use the relation between beta and gamma. So however, let's start with the proof of 0 factorial equals to 1. So first of all, how we can prove? You can see we will be going to use this formula where we have to find out 0 factorial. That means we have to find out n factorial, like n is equals to 0. So gamma n plus 1 is equals to n factorial. So this is gamma 0 plus 1 is equals to 0 factorial. This is gamma 1, this is 1. Right, gamma 1 is equals to 0 factorial. We have to find out gamma 1. Now using the basic formula, which is basically nothing but the integration form of gamma, we can easily use. First of all, this is n should be greater than 0. In that case n is 1 is greater than 0. So you can use the integration format, which is nothing but gamma 1 is equals to what? 0 to infinity e to the power minus x into x to the power 1 minus 1 dx. Now this is nothing but x to the power 0, which is basically 1. So you have to integrate e to the power minus x with the limit 0 to infinity with respect to dx. So the integration of e to the power minus x is nothing but minus e to the power minus x. I'm doing step jump. I'm not explaining this portion. Hopefully you can understand. So this is minus e to the power minus infinity minus plus e to the power minus 0. This is nothing but 0 and this is nothing but 1. So the answer is 1. So 0 factorial is 1. Hopefully you can understand. Using the gamma function you can easily prove that like 0 factorial equals to 1. Now this is all about gamma function. No, this is not all about gamma function, definitely. In the next page I will talk about the beta function. Then I will try to prove the relation between gamma and beta function. Then I will show some beautiful forms of beta function and beautiful forms of gamma function. In the next video I will try to cover some examples. In that video I will try to give some specific theoretical formula, or you can say theoretical values, which you have to remember, like gamma half equals to root over pi. You have to remember this, or some formulas you have to remember. In the next video they will help you. So let's move on to the next page. Let's talk about the beta function. So basically, what is beta function? Beta function is looking like beta n comma m is equals to 0 to 0 to 1 x to the power n minus 1 into 1 minus x whole to the power m minus 1 dx. Now there is a condition for convergence of beta function, which is n comma l should be greater than 0. Otherwise we will not talk about beta function. Even if you want to talk, you can't use this integration, because integration will not converge, it will diverge simply. So we'll not take this integration, you have to deal with some kind of another formula or something like that. So however, in that case we want to deal with that formula, because we are saying that beta function is converging or something like that. However, let's move on to the next proof, which is we have to prove beta n comma m is equals to beta m comma. In some of the questions you may see like beta or something like that. Maybe the examiner is giving beta in that way. Don't worry, both are same. So you have to prove this. So first of all, this is equals to this, right? 0 to 1 x to the power n minus 1, 1 minus x whole to the power m minus 1 dx, and this is equals to 0 to 1 x to the power m minus 1 into 1 minus x whole to the power n minus 1 dx. Now we have to prove both of them are equal. So how we can prove? First of all, you can see the power of 1 minus x is equals to the power of x. So you can take this substitution. Don't take like 1 minus x equals to x. This is not a proper substitution. If we are taking like 1 minus x equals to x, then the solution of this equation will be like x's will be cancelled out, and if we are even adding x both sides, then we will get 1 is equals to 2x, right? And x equals to half. If we are putting x equals to half, then we will get something like that. So you can put this, but it is like kind of basically you should not do this or something like that. In the end of the day, we will take x. However, it is little bit confusing, I know, but just take this substitution, just remember that. Okay. And why we are taking 1 minus x? Because the power of 1 minus x and x are same, right? So minus dx is equals to dz. So dx equals to minus dz, and from this equation you can say x equals to 1 minus z. Now replace it. Wait a moment, I have to put the limits also. X when we are putting x equals to 0 in that equation, z will be 1. When we are putting x equals to 1, then z will be 0. From this equation you can easily understand. This is the integration from 1 to 0, and this is, we are replacing x with z minus 1. 1 minus z. This is z to the power n minus 1. This is z to the power. I am replacing 1 minus x with z into minus dz. Now there's a rule which is a to b fx dx is equals to minus b to a fx dx. This is the basic rule of definite integral. So you can say we are taking the minus symbol out of the integration, then we will reverse the limits. So it will be becoming 0 to 1 z to the power m minus 1 into 1 minus z to the power n minus 1 dz. Now it is looking very similar with that. Just you have to replace z with x. Now there is another rule of definite integral where we will deal with something like that. Let's say a to b is equals to a to b fz dz. From this we can replace x with z, or you can say we can replace z with x. So 0 to 1 x to the power f minus 1 1 minus z. Even you don't need to change it, you can easily say this is beta n comma m, or specifically beta m comma n. So you can easily prove beta n comma m is equals to beta m comma n, because the function, the beta function is not depending on the variable properly, right? doesn't matter whatever the variable is. Beta function is not depending on the variable. Maybe the variable is z, maybe the variable is x. Just you need to convert the function into that format. I mean, fz or fx into that format, so that we can convert it into beta function or something like that. This is the basic proof. Now let's move on to the like relation between beta function and gamma function, which is too much important for any kind of question. Even if examiner will give you the question like let's prove the relation between beta function and gamma function, so let's prove it. So first of all, before going to the proof, I want to prove another thing, which is, wait a moment, let's me scroll down. Well, this is nothing but a to the power n. Now what is that? Actually we have to prove that. How we can prove? So basically you can see, just say x, we have to make this is also x. So basically you have to replace x equals to z. The limits will be same. Let's say this is x, this is z. If we are putting x equals to infinity, this is also infinity. If we are putting x equals to 0, then z will be also equals to 0. So 0 to infinity. But what about dx? Dx will be equals to dz by a, and we can replace x is equals to z by a. Right? Hopefully you can understand. So this is, we are replacing e to the power minus ax, right? And e to the power minus x, so e to the power minus z, because we are replacing ax with z, so this will be minus z. This is z by a, because we are replacing x as that, and dx is equals to dz by a. Now it is very simple. 0 to infinity e to the power minus z, this is z to the power n minus 1, this is dz whole divided by a to the power n minus 1, and this is also plus 1. I'm doing a little bit step jump, hopefully you can understand. This is nothing but the gamma function. This is gamma n, and this is a to the power n. So you can easily prove that. Using that proof, we will be going to prove the relation between gamma function and beta function, which is the easiest way to prove. Otherwise you can go through the improper integrals to prove that, which is too much complicated. So even you can use the polar coordinates form also, and even you can use the double integral also, which is basically nothing but the polar coordinates. However, I will talk about the very simple way which you can use in your exams or something like that. So let's move on to the next proof, which is too much important. Even after getting the relation, you will understand in the next video that we are using that relation in multiple cases. Like in multiple questions you have to prove something, then at the end of the day you have to use that relation. So just too much important relation. Remember this relation. Even if you can't remember the proof, just remember the relation at least. It is too much important. So let's move on to the next page for proving the relation between beta function. So basically the relation between beta and gamma function is nothing but beta m comma n is equals to gamma of m into gamma of n divided by m plus n. This is the relation. You have to remember the relation for doing any kind of mathematical questions regarding this kind of theory. So how we can prove? So first of all, can we say that gamma n is equals to y to the power n 0 to infinity e to the power minus x into y x to the power n minus 1 into dx, where y is nothing but a constant. Like in that case we are saying a, in that case we are taking y as a constant, right? We can say, because this is equals to 0 to infinity e to the power minus ax x to the power n minus 1 dx, right? Is a constant. In that case we are taking same thing, we are just multiplying y in both sides, we will get this equation. Very nice. And on the other hand we can say gamma m is equals to 0 to infinity e to the power minus y to the power m minus 1 dy. In that case we are taking y as a another variable, but In that case, as we are talking about dx, so y is a constant. Basically, we will treat y as a constant if we are integrating a function which is basically nothing but a function of x with respect to dx. So it is too much important. Now let's talk about the multiplication of gamma n and gamma m. So this will be equals to double integral, be careful, double integral of e to the power, I am summarizing the power of e, xy minus y. Hopefully you can understand. This is x to the power n minus 1. This is y to the power m plus n minus 1. It is very easy to understand. There will be a dx into dy. Now basically this is 0 to infinity into 0 to infinity e to the power, I am taking y, I mean minus y common. This is x plus 1. This is x to the power n minus 1, y to the power m plus n minus 1. This is dx dy. Very nice. Now let's move on to the next page. Now basically you can see the integration, I mean this multiplication of gamma n into gamma m is equals to integration of 0 to infinity, integration of 0 to infinity e to the power minus, sorry for a mistake, I'm doing a little bit step jump. Ready to go? Hopefully you are ready. Now 0 to infinity x to the power n minus 1, 0 to infinity x plus 1 into y, y to the power m plus n minus 1 dx dy dx. Hopefully it is visible. Now basically let's talk about the gamma m plus n divided by x plus 1 whole to the power m plus 1. This is nothing but equals to 0 to infinity e to the power minus of x plus 1 into y, right? In that case x plus 1 be, I mean x plus 1 will be treated as a constant because we are taking dy e to the power y to the power m plus n minus 1 into dy. Very nice. So you can replace this portion of the total integration with gamma. Sorry for a noise. Some riders are doing riding, which is basically a kind of nonsense in that case, because what I am saying, we should focus on the main question. So basically we can replace the inner integral with that, right? So this is 0 to infinity x to the power n minus 1 into gamma of m plus n by x plus 1 whole to the power m plus n, hopefully it is visible, into dy. Sorry, dx. Now beta function will be equals to 0 to infinity x to the power n minus 1 into x plus 1 whole to the power m plus 1, m plus n, sorry, dx. This is another form of beta function, beta m comma n or n comma n, doesn't matter. So this is another form of beta function. In the next video I will try to prove that also. This is another form. Just have to replace like you have to just take a simple substitution for getting that proof. So however, in that video I am not going to the main proof. Let's focus on the main proof. So basically we can replace this portion again for a noise. Sorry, however, so basically we have to make so basically this portion, I'm sorry for noise, however we have to make this portion because this is constant, this is gamma m plus n into this is beta, so beta n comma m or whatever is equals to, we have got this by multiplying gamma n into gamma m, right? So gamma n into gamma m is equals to beta of n comma m into gamma of m plus n. Now I am dividing gamma of m plus n at both sides, so we will get n gamma m whole divided by gamma m plus n is equals to beta into n comma m. This is the proof which you can see here. So this is the proof. Hopefully you can understand. uh, this is all about this video, and the next video I will talk about this proof and some another form of beta and gamma function, so that you can understand. And in the third video I will try to cover some examples. Basically I have seen that this is very vast topic, so we need to talk about carefully, otherwise maybe you will forget something. So we will talk about it very deeply, so that you will not make any kind of mistakes during exam. Thank you for watching my videos. If this video helps you, then subscribe, comment, like, whatever you want you can do. And goodbye.